Hello everyone, and welcome back to the Fluctus Channel. Since the dawn of stealth technology, military aviation has been transformed forever. Nothing embodies stealth better than the F-35 Lightning II. Development of the F-35 Lightning II, a fifth-generation multi-role stealth fighter, commenced in the 1990s. Conceived under the Joint Strike Fighter (JSF) program, it took to the skies for the first time in 2006 and achieved initial operational capability (IOC) with the USMC in July 2015. On LHA-class amphibious assault ships, the F-35B employs short takeoff and vertical landing, STOVL. The F-35B hovers via its directed thrust system for vertical takeoff. It can accelerate along a short deck using its lift fan and rear swivel nozzle angled down and backward for extra thrust, becoming airborne even with heavier payloads. For landings, the F-35B approaches the deck at a moderate speed, redirects thrust downward, and descends vertically. These maneuvers are made possible by the F-35B's advanced propulsion system, which integrates a Rolls-Royce lift system and a Pratt & Whitney F135 engine. Landing on Royal Navy Queen Elizabeth-class aircraft carriers operates on the same principle as on a U.S. Navy LHA. One distinction is that the Royal Navy often conducts rolling vertical landings, RVL, moving forward while descending. To enhance its STOVL capability, the F-35B uses the ski jump ramp for takeoffs. The aircraft angles toward the ship's bow ramp during launch preparations. As the F-35B accelerates along the flight deck, the vectored thrust system engages. The curvature of the ramp tilts the aircraft's nose upward as it climbs the ski jump. This upward trajectory, combined with vectored thrust, generates additional lift, allowing the F-35B to take off with a heavier payload and a shorter deck run than a level deck would allow, greatly increasing operational flexibility and combat payload options. On LHA class, landing helicopter assault class, amphibious assault ships, up to 20 F-35Bs are stored on the main hangar deck. When an F-35B Lightning II lands on the flight deck of a Tripoli or America-class amphibious assault ship, it enters ground operations mode. The pilot deactivates the lift fan and engages the wheel braking system. Ground crew, known as plane handlers, attach a tow bar to the F-35B's nose gear under the supervision of a yellow-shirted aircraft handling officer. The aircraft is then towed to an elevator platform by a tractor, usually an aircraft towing tractor. Once secured, the platform lowers the aircraft to the hangar deck. Below deck, handlers employ precise, coordinated actions to park the jet, where it is chalked, tethered, and subjected to any necessary inspections and maintenance. There is a reason more than 1,000 F-35Bs are operational or on order worldwide. These jets are assembled at Lockheed Martin's aeronautics facility in Fort Worth, Texas, with additional production lines in Cameri, Italy, and Nagoya, Japan. F-35 assembly demands precise engineering, as major airframe components, fuselage, wings, and tail sections are integrated in a complex choreography. Guiding lasers, known as a fingerprint measuring system, FMS, ensure accurate alignment, guaranteeing a seamless fit essential to the aircraft's stealth profile. The U.S. Air Force SBIR, Small Business Innovative Research, program has also facilitated smaller businesses' participation. The F-35 is powered by one of the world's most advanced engines, the F-135. The Pratt & Whitney F-135 engine not only produces over 40,000 pounds of thrust, making it the most powerful fighter engine globally, but it also features adaptive performance for exceptional fuel efficiency, a reduced thermal signature, and the ability to achieve supersonic speeds and STOVL operations. All of this is realized while maintaining cutting-edge stealth technology in its design. For the F-35B, an additional lift fan system was developed. Rolls-Royce's innovative lift fan system enables STOVL capabilities critical for shipborne missions. Positioned behind the cockpit, the lift fan engages during vertical maneuvers, with doors opening above and below the fuselage to channel air downward for lift. This modular system is designed for rapid roll-in divided by roll-out maintenance, allowing technicians to insert or remove it quickly, minimizing downtime and maximizing operational readiness. There are 3 F-35 variants. F-35C, used by the U.S. Navy from aircraft carriers, is designed for operations from smaller carrier flight decks and differs from the F-35A and F-35B in several key ways. It has wider wings, covering 620 square feet, folding wingtips for better deck storage, and larger control surfaces for improved low-speed handling during carrier landings. Its reinforced landing gear, with 2 front wheels, withstands catapult launches and arrested recoveries. During launches, the F-35C's launch bar connects to the catapult shuttle. After deck crew inspection and the shooter's signal, the jet is propelled forward by either steam or EMALs. Upon recovery, the F-35C deploys its tailhook to engage the arresting wire, decelerating rapidly. Guided by the optical landing system, misalignment may require a go-around or bolter. The tailhook was redesigned after testing revealed it frequently missed arresting wires. On a U.S. Navy carrier, pre-flight operations are meticulous. Under intense floodlights at night or during the day, deck crews swarm the flight deck performing final checks. Pilots receive mission and weather briefings. Weapons are carefully loaded, and fuel technicians fill the tanks. The deck, coordinated by flight deck officers, functions like a finely tuned machine, with every person and process synchronized for the launch sequence. All procedures are designed to mitigate the inherent hazards of operating immense power in confined spaces. On average, 1 flight deck crewman visits the sick bay daily. Hazards include flying debris from jet engines, constant aircraft operations, moving arresting wires, and the presence of fuel and high explosive munitions. Even in flight, challenges persist. The angle between oncoming air and the wing's chord line is the angle of attack, AOA. Like other aircraft, an F-35C at high AOA may approach stall conditions. To recover, the pilot lowers the nose and accelerates to regain lift and control by pushing the stick forward and increasing throttle. The F-35C has systems to prevent stalls or recover automatically. High-angle attack tests are conducted to validate these systems. Once operational, F-35Cs were delivered to initial carrier fighter squadrons. Flight deck operations require precise coordination from primary flight control, PRI-FLY, to deck crew. Aircraft on deck and in the air are tracked via the Ouija board, in communication with catapult officers, shooters, managing the Integrated Catapult Control System, ICCS, or bubble. Coordination extends to the engine room, essential for maintaining precise speeds for launches and recoveries. Nuclear reactors and boilers generate steam, transmitted through reduction gears to propellers. Throttle operators adjust engine output according to deck officer directions. Carriers sail into the wind for optimal lift during launches, and speeds are fine-tuned during recoveries to maintain a level deck for safe arresting wire engagement. The launch bubble is a central carrier system controlling steam and electromagnetic catapults. The ICCS houses the shooter, who monitors the deck through armored glass. The shooter sets precise energy levels based on aircraft weight and conditions, releasing stored energy to propel the aircraft smoothly down the flight deck from standstill to flight. Aircraft carriers represented a leap in military power, and the F-35 Lightning II further shifted the balance, especially with the Bravo and Charlie models. After years of development and testing, the F-35 is rapidly establishing dominance over the ocean skies. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.